Welcome to qnawire.
Okay, let's go ahead and solve this problem. So we're given the vector f as x plus y squared, comma y plus z squared, comma z plus x squared. Okay, and we are supposed to evaluate a line integral cf dot dr, where c is the curve that's drawn right here. It's an equilateral triangle with the vertices at 1, 0, 0, 0, 1, 0, and 0, 0, 1. Okay, so if we try to evaluate this normally, which is something doesn't seem like it's too complicated to do, but the steps are going to be long because the parameterization of C, we can split it into 3 lines. So we basically have to evaluate 3 integrals minimum in order to solve this problem straightforwardly. But we can use Stokes theorem in order to simplify the process a little bit. So let's talk about that. Okay. So instead of considering C as 3 lines, a curve of 3 lines, I can consider it as an equilateral triangle as the surface S. Okay. And because I know that the plane that contains these 3 lines is the form x plus y plus z is equal to 1. From there, we know that the normal vector is going to have the form 1 comma 1 comma 1. And because when we do a unit normal, when we use a unit normal vector to do the calculation, we just need to calculate the magnitude of 1 comma 1 comma 1, which is equal to square root of 3. So we can actually easily calculate that the unit normal vector is 1 over root 3 of 1 comma 1 comma 1. Okay, so we're going to use that in order to solve the problem using Stokes theorem. And let's recall that this is simply the double integral through the surface S of curl f dot ds, but I will use dot n ds. Okay, S is not the vector, it's just a surface in this particular case. So we would have to calculate what the curl of f is going to be, and that part, the calculation is not that difficult, so I will let you do the part, but it is basically, we calculate it like this, I, j, k. It's an operation to take the derivative, the partial derivatives with respect to x, y, z, and then we take the cross products. So this is going to be x plus y squared, y plus z squared, and z plus x squared. I already wrote it down over here after my work. It simplifies very nicely. It'll be negative 2 of z comma x comma y. Okay, so when we do curl f dot n, what really happens here is that you will get negative 2 over square root of 3, and then you will have z plus x plus y. But what we know about the plane here is that although we have it in a different order, x plus y plus z is equal to 1. So this simply goes away. So you will have negative 2 over square root of 3, which we can pull outside the double integral. Okay, so what we're going to evaluate is essentially negative 2 over root 3, the double integral through s ds. And then I like to use this technique all the time, but we know that this is simply the area of the surface. Okay, now this is an equilateral triangle with side length square root of 2. So the area is root 3 over 4 times root 2 squared. Or in other words, root 3 over 2. So when I multiply that number to negative 2 over root 3, you will get negative 1, and that is the value that we're looking for.